Okay, this is question 9 on the quest review. So it asks us to rotate 180 degrees about the origin, and we must remember this is where the origin's at, 0, 0. Now we could use the coordinates and then use the function notation that we know will provide us with that transformation, which is negative x, negative y. But before I do that, I kind of want to show you the geometric way of thinking about this. So there's an angle from the origin to Q of 180 degrees, which this would make 180 degrees, right? And we have to keep it 1 unit from the origin. So here's our Q prime. Let's look also right here at the other points. So J to the origin. Here we go. Again, 180 degrees. I'll delete this one. That's 180 degrees, a straight line, right? But it needs to be the same distance. So what's the distance? 1, 2, 3 up. 1, 2, 3, 4, 5 over. So you can go 1, 2, 3, 4, 5 over, and 1, 2, 3 up. That would be our J prime. Delete all that. And then do the same thing for our H. So here's H. H to the origin. And then all the way through. That'll suffice. Again, we gotta think about 1, 2, 3, 4, 5 up, 1, 2, 3 over. So go 1, 2, 3, 4, 5 up, and 1, 2, 3 over. And there's our point H prime. Here's a 180 degree rotation. If we were to use our function that we know works, which is 180 degrees rotation about the origin, we could just say, okay, J prime is going to be located at, and our x-coordinate's negative 5, so we need to make that negative as per our function. So negative negative 5 is just 5. For a y-coordinate, again, it's just a negative. You change the sign, so we have 5, 3. Come on now. Q prime, change the signs. Negative 0 is just 0. Negative negative 1 is just 1, right? And then H prime is 3, 5. We're just changing the signs for that one. Okay, those are our values. That works out. There's our 180 degree rotation about the origin. For question 10, I want to show you again the geometric representation, what's going on here. So from the origin to S, and we have to have a 90 degree rotation. And if you don't remember, we know we can get a 90 degree angle if our slopes are opposite reciprocals of each other. So slope from the origin to S, and I'll write that like this. The slope, say slope of OS is up 1 over 1. 1 over 1. So our slope of OS prime, where it's going, needs to be negative 1 over 1. So negative 1 over 1 is like that. Again, it needs to be the same distance. So here's our S prime. Now I'm going to get rid of this just not to confuse you. 90 degrees is easy for this one, right? Because from the X axis, we know that going up the Y axis gives us 90 degrees. Because we know that vertical and horizontal lines are perpendicular to each other. Like you can see right here, this is a 90-degree angle. How many units away? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Here we are sitting at L prime. So let me erase all this. Finally, B, we can do the same thing. One, 2, 3, 4. 1, 2, 3, 4, 5. So rise over run, 5 over 4. So we know that our line that's perpendicular must be negative 4/5. So we'll go up 4. 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. So this point right here would give us that line of negative 4/5. So here is our B prime. We know that between B prime, the origin, and B, we have that 90-degree angle, hence the 90-degree counterclockwise rotation. But this is just a geometric representation. I think it'd be much easier for you to first write out the points. So B is located at 4, 5. S is located at 2, 2. And L is located at 5, 0. And the function for this is, if it's negative y, x, how do we do that with B, S, and L? Well, B prime, okay, we take this y coordinate, change the sign, which is negative 5, and we put it in for the x coordinate. So negative 5, comma, and then we just take that 4 and put it in where the y coordinate should be. So change the sign of the y value and switch the two coordinates. S, so change 2 to negative 2, put it in the x place, negative 2, comma, and then switch the x with the y, negative 2, 2, and then L, negative 0 is just 0, and then we go up 5. And those are the coordinates for our 90-degree rotation of triangle BSL.